All right, now I apologize in advance because I'm sure some of you are going to want to cry after this.
No, it's really hard.
Most of this topic is easy. I'm now going to give you the terrible bit.
No.
I apologize. So, honestly, if it was up to me, this would not be in the course. I think they should put this bit in next year's course, because the problem is I am not going to explain to you why this works.
What?
I can't. That is next year's. I haven't even done it to the grade 11s yet. They don't even know why this stuff works. There is a topic called the unit circle. It is about trigonometry and it applies it to circles and 3D space as opposed to normal graphing, which is what we do. And I cannot explain that to you. That is a very long unit in itself. So what I have to do today, which I think is really dumb, is show you the graphs of trigonometric ratios and just make you memorize them, right? So you don't, if you look at this and you go, holy crap, what the hell am I looking at? Don't worry about it. All you have to do is memorize a couple of different things. If you don't understand it, it's fine. You understand it next year. You just need to be able to remember a few key details. So when it comes up on the screen and you're like, oh, what is happening? Don't worry too much, okay? It's going to look intimidating, but I promise it's not that bad.
Oh, what is happening?
Okay. So let's look at some graphs. So what I'm going to do is I'm going to show you what trigonometric ratios look like as graphs. They are going to look nothing like any graphs you've seen before. This is a sine wave. So what this means is that the graph of sine equals x moves around like waves, right? I mean, to a point, there are some similarities between those ideas, right? So I'm just going to point out a few things here. So let me get a more obvious color. All right. So you can see here that it crosses at 0, 0. That is the start of the graph. Let's ignore the negative side for now. Let's just focus on the positives. If you have a look at this scale, see how I'm going up by a lot. Like this only goes up to 1 and 2, but this is 100, 100, 200. Sorry, 100, 200, 300. Which makes this 360. What's 360 degrees? A circle. So see how this pattern repeats once every 360 degrees. So that really means, that's what I mean by unit circle, okay? Again, you don't need to know all about that, but what is happening is every 360 degrees, this wave repeats itself. So if you go back here, this is negative 360, right? It's going backwards. The same thing happens every 360 degrees. We just go up and down. The top point here is 1. But if this is halfway through the pattern, or sorry, a quarter of the way through the pattern, what's it going to be? 90, which makes this 180, and this 270, and this is -1. So think about this as like, think about a circle, right? If I've got my north, south, east, west, right? Think about north, south, east, and west, right? This is my 90 degrees. That's 1/4. This is 90 degrees. That's 1/4. This is 90 degrees, quarter, 90 degrees, 1/4. That's what's happening here. You get up to the top, that's a quarter. You get back to the middle, that's a quarter. You get down to the bottom, that's a quarter. You get back to the middle, that's a quarter, right? So every 90 degrees, you hit an important point. That's all you need to know. We go, well, I'm not done. That's all you need to know about this bit, right? So those are the important points. So if you were asked to draw a sine wave, that is all you would need to draw. From 0 to 360, we go up to 90, down to 270, over to 360, it goes up to 1, down to -1. It's not opposite, but it's the same, but it starts at 1 instead of 0. I'll show you that in a second. So this is the sine wave. Okay, so we start at 0, we end at 360. Every 90 degrees, we hit an important point. Does that make sense? Okay, the cosine wave is exactly the same thing, but we start at 1. Hello, oh, right, I've got the annotate bit on. Okay, so see how it's exactly the same thing, but let me get another color. It starts at 1 instead, right? Then when we get to 90, we're at 0. Then when we get to 180, we're at -1. Then when we get to 270, we're at 0. Then when we get to 360, we're back at 1. All right, so it's exactly the same. You just shift it forward 90 degrees, right? So we're starting at 1 instead of 0. But apart from that, it's exactly the same. That's the only difference you need to know between them, where it starts. Apart from that, they are the same thing. Do we get this so far?
No.
That's okay. It's okay. Okay, so think about exactly what I'm drawing here. This time we're starting from this bit, right? This is our starting point, the east. We start at 90, right? We're up here. Well, I suppose that's not actually, that's not very helpful at all. Ignore I said that. That is not a helpful thing to say. All we're doing is, so for the sine wave, you start at 0, and for the cosine wave, you start at 1. Apart from that, every 90 degrees, you'll add a new point. So every 90 degrees is a point. So we go 0, 90, 180, 270, 360. These are our 5 points. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Either way, we have 5 points, start and finish. Every 90 degrees is a new point. You should always end up where you started. So if you start at 0, you end at 0. If you start at 1, you end at 1. The same would be true if you went backwards. Every 90 degrees, you hit a new point until you're back to where you start at -360. Or here, every 90 degrees, we hit a new point until we're back at -360. Okay, I get this is all a lot. That's okay. There are also algebraic rules so that you do not have to use, they're easy. They're like beyond easy. They're like grade 6 easy. So if you do not have to draw a wave or a graph, don't, right? They are complicated and unnecessary. Sometimes they will ask you to draw one, so you have to, but if they don't ask you to draw one, please don't bother. I'm going to save this. Right, so let's go to, oh, I'm still annotating. Let's go to a whiteboard. All right, I'll go back to Desmos in a minute. We're going to stick with the sine and cosine waves right now. So I'm going to show you the very, very easy algebraic rules. This is what you should use most of the time. Don't use waves unless you have to. So there are, oh, actually, should I show you that on? Maybe I should show you that. Okay. Okay, sorry. I'm just going to go back and show you one more thing. Let's go back to sharing this. Okay, let's go back to this for a second. So here, if I said that sine equaled 0.5, right? Let's get, actually, first of all, let's just get rid of the cosine wave because we don't want that right now. Go away. All right, so if I had the sine wave, oops, and I've drawn on it as a cosine wave, haven't I? All right, so let's say that I wanted where sine is 0.5, okay? Sine is 0.5 here, right? That's the value of sine, 0.5. There is another answer, right? You can see that there are two answers. When y is 0.5, there are always two answers. If I wanted y to be 1, well, that's not very helpful. Let's go to something like this, right? What do you mean? This is the y-axis, this is the x-axis, right? That's all I'm talking about. Yeah? So I have two values. Wherever I go here, if I'm going down to -0.5, there are two answers. See what I'm saying? There are two, right? What do you mean, what's the answer? No, it's these two values here, right? It's these two values here. Okay, so let's talk about that. What is the answer? Does anybody How did you get that, Josiah? Well done. Right. If I want sine of a half, which is sine of 0.5, right? How do you find an unknown? How do you find it? Oh, sorry. You know what I'm doing? I'm writing that wrong. Sine of something is a half. Yeah. So all I'm doing is the inverse sine of half. If you're asked to find an unknown angle, think of this as your angle, right? X is your angle. And Y is the value of that angle. Okay? Again, you don't need to be able to understand this fully. You just need to remember what I'm saying. If you're not sure, you should be writing this down. The X axis is the angle size. The Y value is the value of that angle. So when I'm saying sine of, I know that the value is 0.5, but I don't know what the angle is. Josiah just typed this into a calculator for me and said it's 30, which means that that number is 30. Okay? The angle is 30 when sine is 0.5. That's what this means. Yeah? Yeah, let me tell you about that in a second. Yeah? What is it? It is 150. How do you know that? Well done. This is 30 away from that side, and this must be a mirror image 30 away from this side. If that's 180, this is 150. So guess what the rule is? Something really obvious. So the other sine angle is the angle, sorry, 180 minus the angle. This is our little rule. So whatever angle you find here by doing this, you just do 180 minus whatever that is, and that gives you the other one. So if I was doing this one here, let's pick another color. So let's say that I was doing 0.2. So this is going up by 0.1. So guys, focus. If this is 0.2, then I'm going to say the inverse sine of 0.2, what's that? What? No, yeah, but I mean, type that into a calculator for me. I want the 11.5. Okay, so that means my other one is 180 minus 11.5. Right? So that's what this one is over here. So what's that? 168.5. That's what this angle is here. 168.5, and this is 11.5. You see what I'm doing? So I want to show you visually why it works, but you don't have to draw the graph if you're not told to. You can just use this rule here. So let's, first of all, let's save that. And then let's go back